In this session, let's try to find out the derivative of x to the power of n exponential function, so that if we know the generic value for n, then you can substitute for x square, x cube, x to the power of 6, x to the power of 25, whatever may be the value. So let's try to generalize this x to the power of n. So for that, I have to understand what is the value of f of x plus h and also f of x. So I will first calculate what is f of x plus h. F of x plus h is nothing but equal to x plus h whole to the power of n. So this is a binomial expansion, so I will expand it. I will have nc0 x to the power of n into h to the power of 0 plus nc1 x to the power of n minus 1 h plus nc2 x to the power of n minus 2 h square. I have to go till I reach ncn x to the power of 0 h to the power of n. That will be my last term. Now what is f of x? F of x is x to the power of n. So now let's try to find out the derivative. The derivative is given by f dash x equal to limit of h tends to 0. I have first f of x plus h, that is nothing but nc0 is 1. So can I say x to the power of n? I'll put it in flower brackets. Then I will have nc1 is n, you know that. X to the power of n minus 1 is x to the power of n minus 1. H to the power of 1 is h plus, if you see the remaining terms, all terms I have, I will just leave it there. I will not simplify them. I will just say nc2 x to the power of n minus 2 h square. You can see that all these terms have h value which is greater than, which is multiple of h. That means when I substitute h equal to 0, all of them will become 0. Anyway, let me just fill this up. The last one will be ncn. That's nothing but equal to 1, we know that, and that's equal to h to the power of n. So plus the last one is h to the power of n minus x to the power of n. So I can cancel x to the power of n. I am left out with the next step, f dash x equal to limit h tends to 0. I have to divide by h. So I am left with h into n x to the power of n minus 1. You can see the h values is growing exponentially. So hx, h square, h cube. So I can take h common. I will have nc2 x to the power of n minus 2 into h plus this goes on till you go to h to the power of n minus 1, and this I have to divide with h. So let me just change this. This is a curve bracket divided by h. H will cancel. If you substitute h equal to 0, all these terms whatever you have will become 0. So your answer will be nothing but equal to n into x to the power of n minus 1. So just for a recap, nc0 equal to n factorial by factorial 0 into factorial n, or ncr equal to n factorial by r factorial into n minus r factorial. And factorial of a number is nothing but start from the number and multiply every time, successively reducing the number by 1. Like factorial of 4 is 4 into 3 into 2 into 1 till you reach 1. Okay. So what we have done, let me just recap this. X plus h whole to the power of n. So we started with binomial expansion. We expanded that. We observe that the first term and the last term will cancel, because that is first term of f of x plus h is equal to f of x. Out of the remaining terms, only the first term which is left out is having h, Remaining all are multiples of h. That means all of them will become 0 once I substitute h equal to 0. So I am left with n into x to the power of n minus 1. So now I know that if somebody comes and asks me what is the derivative of x to the power of 7, I will immediately say this is n. So n into x to the power of n minus 1 are nothing but equal to 7x to the power of 6. So derivative of x to the power of 7 is equal to 7 into x to the power of 6. Similarly, x to the power of 5 is equal to 5 into x to the power of 4. Or you can try x to the power of half. X to the power of half equal to half into x to the power of half minus 1. You can check with the value we got, that is 1 by 2 root x, or can I say root x by 2x, so that we rationalize, don't have the square root there in the denominator. You multiply again, you will get 1 by 2 root x by x. So let's do some more examples and try to find out the derivative of generic functions like exponential function, constant function, logarithmic function, trigonometric functions, so that we can do some complicated problems in differentiation, finding out the derivatives. Thanks for your time. I'll catch you again. Bye for now.